5.8. Solving inequalities using multiplication and division. When using multiplication and division to solve inequalities, sometimes it looks the same as solving equations. So here are two examples of when it looks the same. You see here 3r is greater than 18. What we want to do is we want to divide both sides by 3 because we want to isolate that r. r is greater than 6. So if I were to plot my number line, infinite going in either direction, my pivot point right here, the important spot, critical point here being 6. And I'm going to have an open dot. Just going to change the colors here just so you can see. And r is greater than 6, so r falls on that red solution. Now with division, now this is kind of a funny one because I can just say, oh, 3p is less than 9. But let's just, go through the rigmarole. Let's multiply both sides by 2 to get the 2 out of the denominator here. So that is 6p is less than or equal to 18. Divide both sides by 6. We have p is less than or equal to 3. So I'm going to have my number line extending infinitely in either direction. My point here is going to be 3, and I am going to use a closed dot because it's less than or equal to, and my solution follows the left. Okay, so it can be 2, it can be negative 50, it can be negative a million, but it cannot be 4. It cannot be on this side. But when multiplying and dividing by negative numbers, something happens to the direction of the inequality. It flips. Here are two examples of when it looks different. See how we are multiplied r by a negative number, and we have divided p, the variable, by a negative number as well. So something happens here. I'm just going to do the long way around just to show you what actually happens, and then I'm going to show you a bit of a shortcut. So if I were to say negative 3r is greater than greater than 18, and I want to keep it positive, what I'm going to do is I'm going to add 3r to both sides. So then I have 0 is greater than 18 plus 3r, and then I'm going to isolate that 3r. So I'm going to subtract 18 from both sides. So I have negative 18 is greater than 3r. Let's pause for a moment. The original question here, the negative was attached to the coefficient, or the negative was in the coefficient of the variable. Here, the coefficient of the variable is positive, but whereas up here, the first line, it's the inequality is pointing the less than bit to the 18, whereas now the inequality is pointing the less than bit to the 3r. So if I were just to flip it, if I wanted to see 3r on the left hand side like we're mostly comfortable with, we had to flip the sign essentially. So then I can say r is less than negative 3, and then I can plot my number line. So this, when we want to keep when we use add and subtraction to keep the variable or to keep the coefficient positive, that takes a lot of steps. Here's something that we can do when multiplying or dividing by negative flip the direction of the sign. So if I'm here, I just, yeah, that's okay. I'm going to divide this by -3 and this by -3. Since I'm dividing by a negative number, I want to flip it. So instead of going in this direction, we're going to go in this direction. -3 divided by -3r divided by -3 is simply r. 18 divided by -3 is -6. So let's just take a boo up here. The direction, since this is all positive, the direction remains the same of the inequality. But look at this. We have this direction has changed. And the only thing that we changed between these two questions is this one's positive 3r and this one's negative 3r. Here, let's look at this one right here. Since we've divided by a -2, and again we can just say 6 divided by -2 is -3, but let's just go along with it. So we want to multiply this side by -2, and we want to multiply this side by -2. So then I have 6p, and on this side I have -18, but since I'm multiplying by a negative number, the direction of the sign will change. It will flip. So let's go back to this one and plot our number line, or plot our solution on a number line. My important point here is -6. I'm going to use an open dot, and r is less than -6, so the solution lies here. For this question here, oh, well, we need to finish it. 6p is greater than or equal to -18. P is greater than or equal to, divide both sides by 6, and it's -3. So I'm going to plot my number line here. My important point here is -3. I'm going to use a solid dot. I'm going to say P is greater than -3, so my solution lies this way. So what about these examples? Does the sign flip or not? And why? Now with this one right here, let's just first solve it. I'm not going to worry about plotting these ones on number lines. Let's just discover whether it flips or not. And the easiest way is just to do the question. So I'm going to divide this side by 3, divide this side by 3, and r is greater than or equal to -6. It does not flip. Because we are dividing each side by a negative number. So let's look at this example here. I'm going to subtract 5 from both sides. 4 x is less than or equal to 4. X is less than or equal to 1. This does not flip because we are not dividing or multiplying by a negative number. What about this one here? We're going to add 2 to both sides. 6y is less than 24. Y is less than 4. And again, does not flip because, and I'm just going to point to this because it's the exact same reason. Yeah, we have subtraction happening on this side, which looks negative, but it's not multiplying or dividing by a negative number, and so it doesn't flip. This answer is negative, but it doesn't flip because we're not dividing each side by a negative number or multiplying each side by a negative number. So, in summary, when we solve inequalities by multiplying and dividing. We must flip or change the direction of the sign if we multiply or divide by a negative number.